Humanity has been bestowed with great gifts. Perhaps greatest of all is our imagination. Because ultimately, it's our imaginations that enable us to shape the world around us. The most obvious examples of that are the great buildings and architecture all around us. But which works of architecture should we see during our lifetime? Find out in Top 10, The Art of Architecture. In this installment, we visit the top 10 designed and engineered bridges of the world, beginning with the oldest and ending with the aesthetic shock of the new. Bridges not only make our lives easier, they can also make the world a more beautiful place. They are a living metaphor for making connections whether you walk or drive over them or pass under them in a boat. So now on Top 10, let's cross over some of the greats in bridge design. Brooklyn Bridge, New York City, USA. The Big Apple in all its glory. You think of the Statue of Liberty, the Empire State and Chrysler buildings, and the Brooklyn Bridge. It connects the boroughs of Manhattan and Brooklyn by spanning the East River. The story of the Brooklyn Bridge has it all: a family dynasty, the American dream, and the very 19th century type of faith in technology as the solution to all our problems. The man you might call the father of the Brooklyn Bridge was an American architect and engineer of German descent, one John Augustus Roebling. Roebling began work on the project in 1867. After his untimely death, Roebling's son Washington Roebling took over construction. Washington decided to use caissons, large watertight wooden vessels which scrape along the riverbed to build the massive foundation of the Brooklyn Bridge.
I think from everywhere, every aspect, all the details even of that bridge, I mean, it feels very European to me, which is the basis of New York. In its beginnings were European, and so it feels like beautiful European bridge architecture to me, but it sits perfectly in New York and in this place.
Construction commenced on January the 3rd, 1870 on the Brooklyn banks of the East River. A caisson sized 50 by 40 meters was lowered into water. After the caisson's steel blades dug deep into the riverbed, the hugely ambitious construction began. There were two groups of workers, one which worked above the waterline on top of the caisson, building the foundation of the bridge tower out of huge granite blocks. The second group worked inside the caisson, digging down until they reached solid bedrock.
You feel that it's a really strong bridge, and you feel like it's going to support you, and you feel in this architecture, this heavy brick and stone architecture, you feel early New York. You know, you just feel that it's in the right context.
Working with the air compression chamber was difficult and dangerous. 27 people lost their lives to make the Brooklyn Bridge a reality. Many of the workers suffered from decompression sickness, including Washington Roebling himself. When the second Manhattan side tower was built, with its foundation laid at much lower depths, Washington fell ill. When he did so, he turned to his wife for support. He explained all the mathematics and mechanics of the bridge's construction to Emily so that she could take over in the event of his death. In the end, it was Emily Roebling who saw the project to completion.
It remains the oldest suspension bridge in the USA and continues to be a historical landmark. It's an integral part of the New York skyline.
When both bridge towers were finished, they stood over 80 metres above water level, instantly becoming the tallest structures in the Western Hemisphere at that time. For its day and age, before electricity, the motorcar and skyscrapers, this was astonishing. Brooklyn Bridge was inaugurated on May the 24th, 1883. 1,800 metres long, and with a span of nearly 500 metres, it was until that time the largest suspension bridge ever built. It cost $15.5 million, an enormous amount of money at the time. Over the decades, this national landmark has been reconfigured to include a 6-lane road and a path for pedestrians and cyclists, but lost nothing of its charm. Dom Luís I Bridge, Porto, Portugal. In the Portuguese city of Porto, known for its sweet dessert wines of the same name, you will find one of the most beautiful bridges in the world. The Dom Luís Bridge is located in the historic centre, high above the valley over the river Douro. The magnificent bridge was built in honour of Ludwig I, the Habsburg King of Portugal between 1881 to 1886. The architect was the German designer and engineer Theophile Seyrig, a disciple and colleague of Gustav Eiffel. Yes, that's as in the Eiffel Tower.
This bridge hit a record for the biggest trussed arch bridge at the time it opened. It's an elegant structure, and its filigree-like construction gives it a special lightness.
The so-called truss arch construction of the Dom Luís I Bridge uses thousands of triangular or rectangular bars which give it its strength to withstand the elements. This double-deck bridge, intended for horses and carts, but carrying trams and automobiles to this day. When it was built, it was the world's longest bridge for a while.
The height difference in the points of movement is the fascinating part, that there are the cliffs on the top and how there can be this movement on this upper level and the lower level. You know, it's a little bit nervous looking, especially if you've experienced it.
The bridge obviously fits in quite splendidly with the local topography. But it's a thing of beauty from an engineering perspective too, not just a scenic one. Its finished structure comprised of sets of triangles and gives the Dom Luis I Bridge its distinctive appearance. In the 19th century, the supporting structures of these massively ambitious engineering projects were worn proudly and on the outside. It was engineering architecture and its bold structures that inspired Le Corbusier in the early 1920s to write his manifesto Toward an Architecture, containing the famous advice, "Let us listen to the counsels of American engineers, but let us beware of American architects."
Discover the past with exclusive history documentaries and ad-free podcasts presented by world-renowned historians, all from History Hit. Watch them on your smart TV or on the go with your mobile device. Download the app now to explore everything, from the wonders of ancient Pompeii and the mystery of the princes in the tower to the life of Anne Boleyn and D-Day. Sign up via the link in the description.
This bridge in particular is very strong in its expression of the two types of visual movement of the arch and the straight parts. But it's fascinating that somebody would use this combination.
At any rate, the Dom Luis I Bridge was opened on October the 31st, 1886, and a year later, the lower deck intended for normal ground transportation was opened as well. Porto in those days was still at the crossroads of once popular trade routes. When the bridge opened, it was a welcome shortcut for weary travellers who had been used to traversing the deep valley of the River Douro. The city itself is no longer the market hub it used to be, but the presence of bridges in the Portuguese city is still a quintessential part of the skyline. The most imposing bridge of all is undoubtedly the Dom Luis I Bridge. Tower Bridge, London, United Kingdom. In the heart of historic London is one of the most famous bridges in the world, the Tower Bridge. It spans the River Thames, with Southwark on the south bank and Tower Hamlets, and the East End on the north side. The East End was originally located outside London city walls. It was a place where the ships had been built and repaired since the Tudor era. But in the second half of the 19th century, it transformed into a centre of industry and commerce. Building developers, industrialists, and immigrants all would benefit from a new bridge. A special expert committee was established in 1877. Eventually, the board announced a tender to which more than 50 proposals were submitted. The winner was the project from city architect Sir Horace Jones. He would die shortly before its completion.
The neo-Gothic style of this bridge and the combination of a suspended bascule bridge makes this piece of simple engineering work unique in this city.
The bridge's engineering works, with attention to the retractable deck, were drawn up by Horace Jones' chief engineer, a certain John Barry. Barry designed a two-tower bridge, where the two halves of the deck can be lifted up to allow a ship to pass through. To shorten the section of the deck which has to lift up, the bridge's two towers were set on pillars in the middle of the river bed, instead of on the river banks, as you might expect.
The confidence in it, the way it was designed, the confidence within which different systems of engineering were combined, it's even expressing how at that moment in history engineers could do it this way.
To protect the steel core of the bridge, some parts of the bridge were covered by Cornish granite and Portland limestone. The up and down bridge deck was initially powered by a steam engine, later replaced by engines installed in the tower's foundations. In order that passing ships not disrupt pedestrians, two separate covered walkways connected the two towers. After Horace Jones' death, the legendary George Stephenson, so-called father of the railways, took over the project. For one thing, he changed the architectural design of the bridge towers, which Jones planned to cover with bricks. Stephenson chose a more decorative style of the then fashionable Victorian neo-Gothic. London Tower Bridge, an incredibly elegant drawbridge, was opened for business on June the 30th, 1894. The ceremony was attended by royalty, in this case the Prince of Wales, the future King Edward VII, and his wife, Princess Alexandra of Denmark. Anyone with an interest in the history of this beautiful engineering structure can visit the excellent interactive exhibition located inside the bridge. The Tower Bridge's high-rise footbridge with a modern transparent floor offers some of the most breathtaking view of the modern metropolis, London. Harbour Bridge, Sydney, Australia. Sydney, Australia's largest city, is renowned for its far from ordinary opera house, looking out onto Sydney Harbour, which of course is spanned by that architectural icon and Australian symbol, the Sydney Harbour Bridge. The idea for the bridge was first floated in the year 1914, the year the First World War broke out half a world away. That was when a certain John Bradfield, the chief engineer of Metropolitan Railway construction, came up with the idea of a cantilever bridge without piers, anchored on the seabed. But it would not be until 1930 that the bridge would finally be completed. The regulations from construction permits had to be rewritten to allow the bridge to be built. The tender to undertake construction was eventually won by the English company Dorman Long and Company Limited from Middlesbrough, which had rich experience in constructing large steel arch bridges. By 1926, the groundwork was completed to enable building of the massive foundations of the bridge towers. At the same time, deep in the ground next to the bridge piers, foundations were built into which steel cables were anchored to secure the bridge's unfinished arch from collapsing.
This arch bridge has a pillar at either end. These pillars also have another function, apart from supporting the load from the arch of the bridge.
Construction of the arch, known colloquially as the coat hanger, began in 1928. Over a period of 13 months, material and workers were transported to their destination by two large cranes moving on rails, and the arch bridge was painstakingly assembled. Thanks to flawless calculations and synchronized workflow, the two arms linked together exactly on August the 19th, 1930. After the last bits had been riveted together and the securing cables removed, cranes started to gradually enlarge the deck in both directions, from the middle of the arch. Finishing the deck lasted until June of the following year. The final steps included removal of all support structures, completion of the monumental granite pylons, and preparation for a load test. The load test lasted 3 weeks, during which time the bridge bore the weight of 96 steam locomotives.
The concept to show the technology of the time and to show the vaulting, the arch which is still suspending the platform below, was important. And there could have been other types of bridges there, but there was the desire to celebrate the passage there.
These days, the Kotanga is an extremely important arterial road. Every day, some 180,000 vehicles cross over it. In addition to its 8-lane road, the Sydney Harbour Bridge has 2 railway tracks, a bicycle path and sidewalk for pedestrians. If you appreciate unforgettable views, you can climb to the top of the arch of the bridge and look out over the bay and the city. This activity takes around 3.5 hours, but for many, the feeling of having the whole of Sydney at their fingertips is well worth it. Golden Gate Bridge, San Francisco, USA. San Francisco's famous Golden Gate Bridge has spanned the Golden Gate Strait for almost 80 years. It's a symbol of the city and of Californian cool. Yet the Golden Gate is subject to harsh weather conditions at times, with sudden gusts of wind, temperature fluctuations, and strong sea currents bashing against the shores. But the extreme environmental conditions were not sufficient to discourage Joseph Behrman Strauss, the spiritual and actual creator of the Golden Gate Bridge. Strauss, an American-born structural engineer, had the dream of building a bridge that would exceed all existing bridges in every important respect. His opportunity came when the city of San Francisco announced its intention to build such a bridge across the Golden Gate Strait.
The best results are achieved when an excellent architect and designer meets an excellent structural engineer, and everyone involved works together to develop the structure.
Work on the Golden Gate under Strauss's supervision began in 1930, with the cooperation of the engineer Leon Moiseff and the architect Charles Ellis, who lent the bridge its memorable Art Deco appearance. The most difficult part was the building of the foundation for the southern pillar. This is located 300 metres, 984 feet, away from the shoreline, some 30 metres, or 98.4 feet, deep. The next step was to build the massive foundation plate of the south pylon. No easy feat.
Problem of that bridge is that the weather, the clouds pull into the bay, they completely mask the bridge, and you have no feeling of its presence. But to watch the clouds disappear and the sun take over and illuminate this fantastic structure, it's a very breathtaking experience.
After the completion of the concrete plates that are the bridge's foundation, came the construction of the towers riveted from huge steel segments. For each tower, about 600,000 rivets were used. Workers on the bridge, charged with making sure every single one of those rivets was screwed tight, operated along an intricate maze of corridors with 90 different routes linked together by 27 ladders. Both pylons were completed in the summer of 1935. At 227 meters, or 745 feet, they immediately became the highest bridge structures in the world. In the autumn of the same year, springing of support cables began. The construction of the monumental bridge was at last completed. On May the 27th of 1937, the day the bridge was inaugurated, 200,000 citizens of San Francisco took the opportunity to cross the Golden Gate Bridge. Annual maintenance is the work of 28 painters, whose task it is to prevent corrosion at critical points. There's a myth that the bridge is being continuously top-coated, but in actual fact, it has been painted anew only twice. Nevertheless, few would dispute the claim that Golden Gate is among the most photogenic bridges in the world. The second half of the 19th century was a golden age of invention, with unprecedented advances in science and technology. It was largely thought advances in construction mechanics and metallurgy that projects only dreamt about before could be turned into very tangible reality. The following 5 bridges belong to the recent past. They can all be said to be associated with developments such as globalization that are particular to the last 50 years. Erasmus Bridge, Rotterdam, the Netherlands. The Netherlands may be a small country, but it undoubtedly ranks among the world powers, at least in terms of architecture. This country has a rich tradition shaped by generations of fine Dutch architects. But even today, the Netherlands has its architectural world stars. These certainly include the couple Ben van Berkel and Caroline Boos from UN Studio. It is their signature on the project that has become a symbol of the city of Rotterdam. The Erasmus Bridge is a fully functioning work of art in the centre of Rotterdam, bridging north and south. This elegant bridge sits adjacent to the routes of 2 motorway tunnels, Maas Tunnel and the Benelux Tunnel. Open since 1996, its asymmetrical pylon, shaped like an inverted letter Y, rises to a height of nearly 140 meters. The pylon shape, resembling the body of a swan, turns out to be functional as well as decorative.
For this construction, the CAD-CAM method was used. The construction concept and final plans were all created with the help of digital technology.
Because the pylon is not typically straight and conventional, instead being beveled at 2/3, the Erasmus Bridge is much less pressured by physical forces that impact it from support cables. The course of load moments by oblique stray cables is more even on the console pylon than on pylons of usual shapes. Even bending moments are significantly smaller. Originally, the pylon was to be made of concrete, but it turned out to be too expensive and difficult to make. So, in the end, the architects found a way to do it with steel. The southern part of the 6,800-ton heavy steel bridge integrates a 90-metre bascule bridge, which is considered the biggest and heaviest in Europe. The Erasmus Bridge demonstrates what can happen when architects and engineers follow a uniform design principle. These days, constructions like this take in urban planning, infrastructure and public relations. This was the 90s, when architectural software was just coming into its own. Architectural design begins with the initial sketches and ends in the final phases of construction. In this case, 5 differently shaped concrete pillars, fender, harbours, details, fittings, connections and service equipment all had to be designed. The interior of the bridge, which connects the southern part of the city of Rotterdam to the north, conceals a large concrete stairway leading to a parking garage.
Special architecture maybe even can be more remembered for its power at night, because you don't see all the limits that exist in the visual frame of reference during the day.
At night, this unusually subtle bridge wears its air of understated cool well, thanks in part to the play of lights. The Akashi Kaikyo Bridge, Kobe, Japan. The Akashi Kaikyo Bridge is the largest suspension bridge in the world. It is a miracle of Japanese construction and engineering, which links the city of Kobe to Iwaya on Awaji Island and is also part of the Honshu-Shikoku Highway. The idea to connect Awaji with Kobe had emerged at the end of the 1950s in response to the tragedy which occurred in the Bay of Akashi in 1955. Collision of 2 ferries had claimed 168 victims. However, it took more than 3 decades before the bridge was built.
The task of engineering for earthquakes is an immense task, which is, for me, even till now, unbelievable how the techniques of engineering against earthquakes evolved and how they are sophisticated.
But it wasn't political or economic reasons which prevented construction for so long, but the right technological solution. That only came by the end of the 1980s, boom years for Japan. Akashi Bay is a place used to extreme natural conditions. The seabed around here is some 100 meters or 330 feet deep, and the shore faces massive tidal streams at up to 4.5 meters per second. It is close to major international shipping lines, but also located in a typhoon zone. Worse, the bay is located above the border of two tectonic plates and sees frequent earthquakes. These were the factors which had to be carefully considered when designing the giant bridge. The construction of the Pearl Bridge, as the link between Kobe and Awaji Island was nicknamed, commenced in 1988. Work began by building massive bases for the embedding of the load-bearing cables. Simultaneously, construction of the foundations of the future, 300-metre high bridge towers, began on sea. The towers are based 60 metres below the sea surface and composed of gigantic steel cylinders. It took 7 years to complete the two towers and to stretch the load-bearing cables over the bridge deck. When it seemed that the construction was progressing successfully to its completion, a devastating earthquake struck.
Because of the extreme conditions in the region, this bridge was designed to absorb shocks and tremors caused by typhoons and earthquakes. In 1995, an earthquake destroyed many buildings in Kobe, but the nearly completed bridge,
the unfinished Pearl Bridge, miraculously withstood the quake. The opening ceremony was attended by more than 1,000 prominent guests, including His Imperial Highness Crown Prince Naruhito and his wife, Princess Masako. Thanks to 1,737 lights installed on all parts of its structure, the Pearl Bridge lights up in practically any colour. Öresund Bridge, Denmark and Sweden. Öresund Bridge is a critical component of a modern transport infrastructure that connects the Danish capital of Copenhagen with Malmö in Sweden. Altogether, it is over 16 kilometres long and consists of 4 parts: a 3.5 kilometre long underwater tunnel, an artificial, about 4 kilometre long island, a significantly smaller peninsula built up by the Danish shore, and finally the bridge itself, named after the Öresund Strait, which it crosses.
the gigantic proportions of this almost 8-kilometre long structure, the combination of road and rail traffic, and the fact that the bridge connects 2 states and 2 great cities, Copenhagen and Malmö, makes this construction one of the most interesting in the world.
The official contracts for building the Öresund Bridge were signed in 1991, but the idea to connect the 2 countries is considerably older. Architects and engineers had been trying to solve the problem since the 1870s. The most logical idea seemed to be placing the bridge at the narrowest point of the Öresund Strait, between the Danish Helsingør and the Swedish Helsingborn, about 40 kilometers north of Copenhagen. There the waters are only 4 kilometers wide. Eventually, however, the current site was chosen, even though it was 4 times as long. Economic factors and transportation routes had a lot to do with the bridge's final location. Works began in August 1995, with its last part being fitted 4 years later. From a structural point of view, the Öresund connector frame is a mixture of suspension bridge and classical bridge. The length of the whole structure, which is the 2nd longest bridge in the world, is the remarkable 7,845 meters. The first day of July 2000 became an historic day for both Denmark and Sweden, as the Øresund Road and Rail Bridge was officially opened. The first train set off from Malmö to Copenhagen on July the 2nd, 2000 at 6:09 a.m. Vehicles had begun crossing the bridge the night before.
This kind of connection is about freedom. It's about freedom of movement. And I think the bridge, in that part of the world, the bridge has a completely different meaning. I think life probably wouldn't exist normally for them without these bridge connections. And this particular bridge is fascinating that you come in or out through what looks like an artificial island in the water to cross this bridge. So I think it's absolutely amazing.
A combination of reinforced concrete decks with supporting trusses underneath was used in this construction.
Connection of the Øresund shores has not just fulfilled the old dream of the Danes and their Swedish neighbours of shortening the journey between Malmö and Copenhagen to just 35 minutes. It has created a completely new economic region. Gateshead Millennium Bridge, Newcastle upon Tyne, United Kingdom. The Gateshead Millennium Bridge is a pedestrian and cyclist tilt bridge that, once seen, is not quickly forgotten. It spans the River Tyne in England between Gateshead's Quays Arts Quarter on the south bank and the quayside of Newcastle upon Tyne on the north bank. Because of how it seems to open and shut to let ships pass through, locals call it the Blinking Eye Bridge.
It's the first bridge which turns around its own axis to allow ships to go through, and which, when necessary, can raise the whole pedestrian and cycle deck.
In point of fact, its appearance owes as much to function as to form. The whole bridge rotates on the huge joints embedded in the concrete struts on both banks of the river. By turning thus, the bridge allows for the passing of ships below. It's an unconventional solution, but one which really makes this thoroughfare for pedestrian traffic and cyclists one of a kind. The bridge is comprised of two main components: the bridge's structure itself and the mechanism that elevates, or more precisely, rotates it by a few degrees. The bridge is essentially made up of a pair of steel parabolic arcs, one of which is a supporting arch that carries the deck curved in the direction of the river flow using the supporting rods. On the deck, there are two separate paths ensuring safe passage for both pedestrians and cyclists. The elegantly shaped railing is reminiscent of luxury ocean liners from the golden days of cruise ship travel.
If this engineering can inspire people to move, to observe, to appreciate engineering, then it's successful.
The second part of the structure is, of course, the tilting mechanism. It consists of two large cylindrical pins. These not only rotate the bridge, but hold it together. The tilting itself is performed by 6 hydraulic arms. The tilting mechanism of the bridge consists of a pair of parabolic steel arches, one of which forms a curved bridge deck, which is held by the second one, utilizing a system of suspension rods embedded into the giant joints. Tilting of the bridge during which both arches act as counterweights, lasts less than 5 minutes. During this time, anyone waiting impatiently on the banks or at the helm of a boat should thank the sophisticated hydraulic system, run by 8 powerful yet energy-saving electric motors. Each time the bridge tilts, it tidies itself up. Earth's gravity causes all the litter to slide into special bins placed on the bridge deck. A competition to design the bridge was eventually won by the Wilkinson Eyre Architects Studio in London and civil engineering firm of Gifford and Partners. On November 20, 2000, the pre-assembled bridge was delivered to its new home location. Thousands of curious spectators watched its installation. It was performed using a giant floating crane, Hercules II, which was brought by towboats from the Netherlands. They were able to walk the bridge the very same day. The official opening of the bridge, which has since appeared on the £1 coin, was not held until May the 7th, 2002, with none other than Elizabeth II present. Evidently, bridges are a real drawcard for European monarchy. In 2000, the 850-ton bridge was awarded the most prestigious prize of the Royal Institute of British Architects. Millau Viaduct, Millau, France. The Millau Viaduct is a masterpiece of contemporary architectural engineering and a standout even among the quite stupendous bridges of the last few decades.
It definitely, for me, reflects French thinking, that if we can do something grand, if there's a reason to do something grand, and it's fits to the place, let's do something grand. Even grand doesn't mean overdone, but grand can be that let's do the best bridge that could possibly be built here. This is the thinnest bridge, the most narrow columns and towers, and this bridge expresses that.
When French engineers began a new stretch of the motorway A75 between the cities of Ferrand and Béziers near the town of Millau, they encountered what you might call a surmountable problem. There were several ways of traversing the deep valley of the Tarn River taken into consideration. A conventional concrete frame bridge was seriously considered, as were several types of truss and arch bridges. Finally, the designs of the renowned Michel Virologa for a suspension bridge with 8 spans were selected.
The collaboration between architects and engineers to apply new types of technology was very important during the whole construction of the bridge.
The designs of Virologa, one of the best bridge engineers of our time, drew on a combination of concrete and steel, which, if properly maintained, can ensure a working life of at least 120 years. Virologa opted to use steel and concrete, not just because of durability, but because he believed the bridge's finished structure would then be graceful and aesthetically pleasing. He invited the celebrated British architect Sir Norman Foster to cooperate on the final design. Thanks to Foster's artistic aplomb and Virologa's engineering skills, the bridge, despite its size, does not appear bulky. In fact, the contrary. It almost hovers over the valley of the Tarn River. The lightness and at the same time stability of the bridge is ensured by the huge concrete pillars resembling blades of grass. There are 7 of them, with the shortest being 78 meters or 253 feet tall. When you factor in the steel masts on which the supporting steel cables are fixed, the highest pylon reaches a daunting height of 343 metres. Each of the load-bearing reinforced concrete towers sits on 4 cylindrical bases. The lower part of the load-bearing tower is a hollow concrete parallelogram. At height of about 90 metres below the bridge deck, the pillars divide into 2 hollow shafts in a Y shape for good reason. This solution increases the strength of the deck in its longitudinal direction, while reducing the stress caused by temperature change. After they were erected in 4-metre sections, the outer scaffolding slid off automatically and the inner scaffolding was moved with a crane. Supporting truss steel structures were constructed in between the pylons. At the top of each pylon, a specially designed sophisticated hydraulic lifter was installed, whose task was to lift the deck up at regular intervals and move it a few inches closer to the centre of the bridge as it took shape. The construction of the bridge deck is an unbroken steel girder, supported by abutments and 7 intermediate pylons. Work on the deck progressed from both sides at a speed of about 10 metres or 33 feet per hour. After completion of this process, when both parts of the bridge deck had been precisely matched, welders connected the bridge and the steel masts bearing the supporting cables were placed on each pylon. The resulting Millau Viaduct merges harmoniously with its surrounding landscape, another example of how form and function mix. Today's great bridge-building engineering works would not have been possible without sophisticated computers, cutting-edge building technology, and new materials with incredible features. They are fascinating, breathtaking structures that often seem to deny the laws of nature. As long as we need to get from one place to another, bridges will remain inherently linked with the march of progress and of civilization.
Humanity has been bestowed with great gifts. Perhaps greatest of all is our imagination, because ultimately it's our imaginations that enable us to shape the world around us. The most obvious examples of that are the great buildings and architecture all around us. But which works of architecture should we see during our lifetimes? Find out in Top 10, The Art of Architecture. The word megastructure, which in today's world is widely used, is actually made up of 2 words from different languages, Classical Greek and Latin. Mega is derived from the Greek word megas, which means big or huge, while structure originates from the Latin verb strura, meaning to compose, construct, or assemble. So it's fitting that the first megastructures were built by ancient civilizations, especially the Romans, who, going as far back as 2,000 years, managed to cover ancient Europe with a network of paved roads measuring an impressive 150,000 kilometers.
The Trans-Siberian Railway, Russia. One of the most expensive, challenging and daring constructions in world history must surely be the Trans-Siberian Railroad. Even today, more than a century after its first tracks were laid, it remains the longest railway in the world.
This 9,289-kilometre long railway line passes through 7 time zones and takes more than 6 days beginning to end, connecting Western Russia with its eastern coast.
So the Trans-Siberian Highway fulfilled already its all-purpose until today.
It winds through wild landscapes, traverses the wide waterways of Russian rivers and streams, and continues relentlessly through seemingly endless forests. The first point of departure is the Yaroslavsky terminal in Moscow. From the Russian capital, the railway passes through Yaroslav, crossing the Volga, Europe's longest river. At its 1,777th kilometre in the Ural Mountains, the railroad traverses the geographic boundary between Europe and Asia. Yet to come are the cities of Ekaterinburg, Omsk on the river Irtysh, and Novosibirsk, the Ural region's largest metropolis, going over the river Ob as it does so. Close to the city of Krasnoyarsk, the railway crosses over yet another large river, the Yenisei. In Irkutsk, one of the largest cities in Siberia, the railway track passes through the paved shores of Lake Baikal, thought to be the world's deepest and oldest lake. After Ulan-Ude, capital of the Republic of Buryatia, the track leads towards the border with China. At the city of Khabarovsk, it crosses the river Amur. Its final destination is the city of Vladivostok on the Pacific coast. The main track also connects to other lines, international routes such as the China Far Eastern Railway, ending in Beijing, and the Trans-Mongolian Railway, which also takes passengers to Beijing, but by crossing the Mongolian plains.
Russians needed really to have this railway from one eastern side to the western side of the country.
Proposals for a railway line that would connect Siberia with the Pacific coast had been around for a while, but the idea of building a railway line making the vast isolated Siberian territories more accessible became popular in the 1880s, during the reign of Tsar Alexander III. A connecting line between St. Petersburg and Moscow had already been built by 1851. But it took until 1890 before the plans for the Trans-Siberian Railway were officially approved. Sergei Vita, who later became Minister of Finance, was appointed as its director. The track was divided into several segments, and squads of workers moved by stages from each end of the track towards a central meeting point. The construction was not without problems. A lack of time and financial constraints meant that there was not enough money for dynamite, so the workers had to dig all the tunnels manually. Meager wages and poor conditions enticed few, so prisoners and later soldiers were called to work on the railway. But the soldiers refused to work side by side with criminals and rioted. Overflowing rivers, disease-ridden swamps, extreme weather, and back-breaking toil. All these factors plagued the railway's assembly, with labourers forced to work like slaves. Despite such setbacks, the track was finally completed and officially opened in 1905. The jewellery designer Peter Carl Fabergé created one of his famous eggs to celebrate this feat of engineering and bloody-minded determination. Tsar Nicholas II gave the egg to his wife, Empress Alexandra Fedorovna. Nice for some. The New York City subway system, New York City, United States. The New York City subway is one of the most famous transport systems in the world. In its own way, it has become one of the symbols of the city. The subway was opened at the beginning of the 20th century. but its roots go back to the need for a safe and dependable public transport system to relieve the crowded streets of New York. This was already a concern by the mid-19th century. By that time, the United States had become the #1 destination for millions of immigrants from around the world, looking for the chance of a new life. Due to New York City's strategic location on the West Coast, that's where most ships loaded with immigrants were headed.
The best part of it is that actually you go underground, but you also see the city there. You hear the music, people are playing. You actually, it's another world underneath the ground that is super interesting for a city to also have.
Private companies in the 1800s provided the option of horse-drawn carriages, but some means of passenger transport away from street level became increasingly necessary. In the 1860s and 1870s, two-track, steam-powered elevated railroads were built over some of the major avenues. But the very first subway tunnel in New York was initiated by inventor Alfred Ely Beach in 1870. It was only 95 meters long, yet a team of 6 diggers managed to build it in a mere 58 days. It carried just one pneumatic car. Beach's transit became a great attraction, but could not meet public transport needs. After 3 years of operation, the tunnel was closed.
The difficulty of building urban underground railway system was always the interaction between the tunnel and the streets and the houses above. So the engineers had to be very careful.
A significant incentive for building the subway was the great blizzard that struck the East Coast in 1888. It brought surface transport to a standstill, making the benefits of an underground railway line all the more evident. In 1898, central New York and its surrounding towns and villages were consolidated into the city of Greater New York, helping to streamline construction of an extensive underground transport system. The work began with a new century in the year 1900. Tunnels were built from the surface using the so-called cut-and-cover method. The subway was eventually opened on October the 27th, 1904. City Hall, which had financed the operation, initially leased the subway to 2 private transport companies, Interborough Rapid Transport Company, the IRT, and the Brooklyn Manhattan Transit Corporation, BMT. In 1932, another line was built, and this was operated by the city-owned company, the Independent Subway System, IND. In the 1940s, the city bought both private companies. However, even to this day, the lines can be distinguished because of the different parameters of the tracks. IRT operated smaller cars, therefore its tunnels were narrower and turns in the track were sharper compared to those of BMT. Even today, the former IRT tracks are designated as A Division, while the B Division consists of former BMT tracks. Today, the New York City subway has 469 stations, most of which are open 24 hours. The total track length is about 1,000 kilometers, of which more than 700 kilometers are located underground. The rest of the tracks are either overhead or located at street level. In 2014, the subway was host to more than 1.75 billion passenger journeys. The Channel Tunnel, United Kingdom, France. Throughout history, many rulers have aspired to unite Great Britain with France. They have strived for political unification or for more power over both countries with mixed results. However, these two countries divided by the English Channel have been united since the end of 1994 by the railway tunnel that runs under the bottom of the English Channel. The idea to link the two countries was first discussed in the 19th century on both sides of the channel. In 1880, testing and construction surveys were carried out on English and French territories. However, the British backed out over concerns for national security. After World War I, the construction of a tunnel was discussed anew, but without any tangible result. During World War II, after the surrender of France, the British were concerned the Germans might start to dig such a tunnel with the purpose of invading Britain.
I think in general, when you do this kind of mega structure project, what you actually do is in the same as in the internet. You connect people much faster.
The mid-1950s brought about the renewal of geological research. An agreement between the two countries was eventually signed in 1973 by British Prime Minister Edward Heath and French President Georges Pompidou. And a year later, the digging of tunnels began. In 1975, however, the British Labour government called time on the project. It wasn't until 11 years later, with the Conservative Party's return to power, that the agreement was renewed. It was signed by British Prime Minister Margaret Thatcher and French President François Mitterrand in 1986 in the British cathedral city which gives the agreement its name, the Treaty of Canterbury.
Especially for people, if you imagine that you travel from the center of city, from Paris to the center of London in a very short time with high-speed trains, there is nothing to compare.
In 1988, the French began digging a tunnel at Coquelin in the department of Pays-de-Calais, while the British started near the Kentish town of Folkestone. The British used a mole tunneling boring machine for cutting through chalk marl. As originally outlined in designs from the early 1960s, 2 tunnels were made for transportation and a third, located midway between them, was dug for maintenance and service. It's interesting to note that the public was always in favor of an automobile tunnel. Ventilation problems and the difficulty of dealing with traffic accidents, however, provided unassailable obstacles, so it was decided to concentrate on the railway alternative. Nowadays, Eurostar train passengers can travel the 50.5-kilometre-long tunnel, of which almost 38 kilometres lies below the bottom of the English Channel. Obviously, commuters and travellers are catered for by Eurotunnel shuttle. Freight trains are also allowed to make use of the tunnel. Stations on either side of the channel are connected by highways, ensuring better access for those travelling by car or bus. Moreover, at the turn of the Millennium, the British built a high-speed railway track from London St Pancras Station to the Channel Tunnel. The journey from London to Paris only takes 2 hours and 15 minutes. One of the first passengers to ever make the trip on the undersea line was Queen Elizabeth II, who together with French President François Mitterrand officially opened the tunnel on May the 6th, 1994. According to Eurostar, since then, more than 366 million passenger journeys have been made through the so-called channel. The Suez Canal, Egypt. Connecting the Mediterranean with the Red Sea and opening up the shortest route for ships sailing between Europe and Asia, Egypt's Suez Canal is one of the greatest construction endeavours in history. The first channels in the area were created by the ancient rulers of Egypt and Persia, but they gradually became blocked with river sediments and sand from the sprawling desert. In the 15th century, a sea route around the Cape of Good Hope was discovered, but as maritime transport developed, shortening the journey to the Far East became ever more desirable. Attempts to build a channel re-emerged in 1798, with Egypt's invasion by Napoleon Bonaparte. Nearly 60 years later, a French engineer and diplomat named Ferdinand de Lesseps tried to revive the grand scheme.
When you plan the channel as a Suez Channel, you have to choose very carefully the place or the route where the channel will be built.
In 1854, he obtained a concession to build the canal from his powerful friend Said Pasha, a Grand Vizier of the Ottoman Empire. A few years later, Lesseps founded the corporation Compagnie Universelle de Canal Maritime de Suez, in which his patron, Said Pasha, was one of the major shareholders. Under the terms of the contract, Said Pasha was obliged to supply manpower, so he called in Egyptian farmers. The workers were divided into two groups, those advancing north from the newly established Port Said and south from the city of Suez. The two work crews were to meet at the Great Bitter Lake. Said's successor Ismail was accused by the British of exploiting slaves to do the hard work. Ismail promptly dismissed the workers and gave Lesseps money for the purchase of vital construction equipment. Things began to progress much faster. Sand, excavated from the seabed by mining machines, was used in the cement which reinforced the channel's wall and floor. Construction of the 164-kilometre-long canal was finally completed in 1869, when the canal was officially opened.
It's effective, but it's also a very challenge concerning nature and resources. And so for me, nature coming first, and then we have to find out how we can deal with it.
Ismail Pasha had a sense of occasion. To commemorate the canal's opening, he ordered the building of the Cairo Opera House, which staged the premiere of Verdi's opera Aida. The Suez Canal has more than once been caught up in interventions by foreign powers. Nationalization of the canal in 1956 was to be a principal cause of the conflict known as the Suez Crisis. Israeli, French and British forces pushed into Egypt toward the Suez Canal, angering the US and creating a major diplomatic incident. The canal was also extended many times. For instance, in 1956, it had a width of 148 meters. In 2010, that was up to 313 meters. In 2014, work began on the so-called New Suez Canal, a parallel canal between the 60th and 95th kilometers. The new canal is intended to ensure two-directional parallel traffic and accelerate the speed of traffic. The 2001-built El Ferdan railway bridge, which crosses the canal near the town of Ismailia, is to date the world's largest swing bridge. Marmaray Tunnel, Turkey. The Bosphorus, whose shores embrace the Turkish capital of Istanbul, is more than simply a strait between the Black and Marmara Seas. Since time immemorial, it has been regarded as a gateway between Europe and Asia. But the Bosphorus Strait has been an important strategic point since ancient times. The ancient Greeks originally founded a settlement called Byzantium on its banks. The strait was well enough known to be mentioned by the historian Herodotus and dramatist Aeschylus.
To fulfill the kind of green new transport system.
The first person to connect its banks was Persian ruler Darius I. Around 513 BC, he ordered the creation of a floating bridge made up of the hulls of ships from his fleet. In modern times, two suspension bridges span the Bosphorus. The first, named simply the Bosphorus Bridge, was completed in 1973. The second, built in 1988, is called the Fatih Sultan Mehmet Bridge. Both bridges are slightly over 1 kilometer in length. Istanbul, of course, is a teeming metropolis with more than 10 million inhabitants. So it goes without saying that traffic through the straits, whether between sea or land, is heavy. In response to this, the Turkish government at the turn of the millennium decided to build a 13.5 kilometer-long railway tunnel, part of which would run under the bottom of the Bosphorus Strait. The almost 1.4 kilometer long section of the tunnel is more than 4 meters below the tube tunnel. It was also built to withstand earthquakes, something which plague Istanbul. It is made out of fireproof concrete, specifically developed in Norway. The undersea tunnel section, which weighs some 18,000 tons, consists of 11 sections, each approximately 110 meters long on average. The route connects the Kazlishemi railway station, built in the European part of the city in 1872, to the newly built terminal Erlikshejmi on the Asian side.
The Turkish engineers had more difficulty with geology because it's quite heavy tectonic base, and the risk of earthquake was very present.
Construction work was preceded by an archaeological survey of the Yenikapu site on the European shoreline. Intended to become one of the terminals, instead, archaeologists discovered the remains of a Byzantine port dating from the 4th century AD.
If you compare European channel crossings and Turkish Marmaray Tunnel, there are similarities that you connect the continents.
The archaeologists also discovered the remains of 37 ships, ranging in date from the 7th to the 11th centuries. These fascinating discoveries, however, delayed the actual construction work, and the planned opening of the tunnel in 2009 has been postponed more than once. Currently, the reconstruction of the original tracks and their adaptation for use by modern trains is underway. The existing 11 stops will eventually be joined by another 36, connecting the stations Halkale and Gebze, located over 75 kilometers apart. There is a sense in which all these megastructures are children of the 19th century Industrial Revolution and its boundless optimism and faith in technology. For good or ill, and sometimes both, it was this technological industrial revolution which radically changed the shape of the world around us and gave rise to our modern industrialized civilization. The primary needs of this new society included the fast, effective and safe transport of ever greater numbers of people and huge volumes of goods. It was the need for efficient mass transport that gave birth to megastructures and to our contemporary transport infrastructure. Beijing-Shanghai High-Speed Railway, China. The high-speed railway, which links the two Chinese megacities of Beijing and Shanghai, was first launched on June 30th, 2011, and high-speed is an accurate description. While its track is some 1,318 kilometers or 819 miles long, trains move along it at speeds of up to 300 kilometers per hour. With this dizzying speed, the travel time between the two cities has decreased to a mere 5 hours. Yet according to the original plans, the speed of the trains was supposed to be a staggering 80 kilometers faster. However, to run a railway track with operating speeds of 380 kilometers per hour turned out to come with some unforeseen economic disadvantages. The railway's original implementation, whose cost was estimated at $220 billion, was entrusted to the Beijing-Shanghai High-Speed Railway Company. They had to design a track that could sustain 220,000 passengers per day, who at rush hour are transported by trains leaving the stations at 5-minute intervals. The track faces steep climbs as well as numerous rivers and valleys. It includes a total of 224 bridges, 2 of which are truly unique. The first is a 164-kilometer-long bridge system or viaduct called the Danyang Kunshan Grand Bridge, and it's the longest bridge in the world. The second, also impressive, is the 114-kilometer-long viaduct between Lingfiying and Qingxian, and at the time of its construction, the second longest structure of its kind. On the 1,300-plus kilometer journey, there are also 22 tunnels along the way, making up a total length of 16 kilometers. The railway, which surprisingly is not actually the holder of any speed records, is utilized by several types of trains made in China. Firstly, there are G category trains. Their construction and design are based on proven German ICE-3 high-speed trains, deploying Siemens CRH3 technology. In 2011, 92 trains were made in cooperation with this company. They come in 2 designs, with either 8 or 16 cars. Each is equipped with first and second class sections in open space cars, and of course, this being modern China, luxury business class. There are also dining and sightseeing cars located at the end of each train. 65 of the trains travel at 300 kilometers per hour, while the rest are about 50 kilometers slower. It is also possible to travel the track at night in sleepers. Preparatory construction work began in April 2008, while track laying commenced 2 years later. High-speed railway construction was completed on February the 4th, 2011, thanks in large part to the 130,000 labourers who worked on the assembly of this ultra-modern transport system. The Honshu-Shikoku Bridge Project, Japan. The Honshu-Shikoku Bridge Project is a transport system connecting the largest Japanese island of Honshu with Shikoku, the country's smallest island, once only accessible by sea. The system, which itself has become synonymous with the word megastructure, is made up of 3 sections. The idea of connecting the 2 islands first gained popularity in the late 1950s in response to a tragic accident that occurred at Akashi Bay. The collision of 2 ferries claimed 168 victims. But it was a full decade before the Japanese government would venture on such a complex and expensive project. It was not, however, political or economic reasons which prevented construction from going ahead for so long, but the absence of technology for building bridges in this tectonically active area, technology which only emerged in the early 1970s.
When Japanese tried to connect the bigger cities in Japan, they had no choice than to fight very difficult conditions, mountains, the seas, the bays, and also the conditions like earthquakes.
Preparatory work started with a field survey in 1970, but construction itself was delayed due to the oil crisis of 1973. Implementation of the first stage lasted a decade and cost $7 billion. More than 3.5 million cubic meters of concrete and 705,000 tons of steel was employed in the process. And although stringent security measures were applied, this gigantic project still cost 13 lives.
All megastructures are exposed to the weather. So the weather influences a lot the structures, its materials, and very often its lifetime is very short.
The first of the 3 sections is 46.6 kilometers long and consists of 9 suspension bridges connecting the 7 small islands. This route also includes a dense network of access roads and feeder roads. The second route, called the Central Route, due to its position, is 32 kilometers long and together with a railway track for Shinkansen high-speed trains, has been in operation since April 1988. It passes through a set of 6 bridges, 9.5 kilometers long in total. The last of the 3 sections is, at 89 kilometers, the longest. Due to its geographical position, it is known also as the Eastern Route. It incorporates the longest suspension bridge in the world and one of the most beautiful of all Japanese bridges. The Akashi Kaikyo Bridge, nicknamed the Pearl Bridge, spanning a staggering 3,911 meters, the Pearl Bridge was completed in 1998. The Honshu-Shikoku Bridge Project, which has contributed to the development of Japan, not least as an economic powerhouse, was not completed until 2006. It consists of a system of double-story, mostly truss suspension bridges. Japanese engineers deployed concrete and steel in the construction of these bridges, as well as that high-end technology and know-how that is justly celebrated around the world. Highway 1, Australia. Although Australia is planet Earth's smallest continent and a country with a human population smaller than that of Tokyo, it has one of the longest road networks on the planet. The Australian National Road, known as Highway 1, is a ring road leading anti-clockwise from Melbourne to Adelaide. It is 14,500 kilometres long, 9,000 miles, and winds its way through major Australian cities such as Sydney, Brisbane, Cairns, Darwin, Broome, Perth and Carnarvon. Up until 1941, Western and Eastern Australia were connected solely by telegraph and railways. The first modern highway in Australia was only built during World War II by the Army, in cooperation with the Office of Allied Works Council, established in 1942. After the war in 1947, the government adopted a new road law.
The Highway 1 in Australia was actually planned. It was not created by centuries from small roads to bigger roads and then to highways. It was really planned.
The construction of Australia's Highway 1 began in earnest in 1955. Yet Highway 1 is not a motorway in the true sense of the word. It is more like a standard 2 or 3 lane road. The third lane here is the passing lane, or overtaking lane in Australian English. Actual motorways of the European or American type with grade-separated intersections are rare in Australia. Such motorways have only been built in recent decades, especially near the largest cities. Many sections are therefore still under construction. An interesting feature of some highways or freeways, as these long-distance roads are called in Australia, are their side lanes for cyclists.
So it's a highway that encounters all possible engineering problems you may have.
Speed limits are generally 110 kilometres per hour. But in the Northern Territory, a car can hurtle along some 20 kilometres faster. Anyone who decides to travel around Australia by car and take the circular Highway 1 must take into account the fact that the network of gas stations and rest stops are quite often located 100 or more kilometres apart. Highway 1 is the only Australian road to which all major roads are connected. There are about 813,000 kilometres of roads on this continent, 472,000 of which are paved roads. The rest consist of local and country roads, of which around 20% are dirt roads and only traversable 7 to 8 months of the year. Panama Canal, Panama. Since 1914, the continents of North and South America have been linked by a canal built in the Isthmus of Panama, a thin strip of land that lies between the Caribbean Sea and the Pacific Ocean. Plans to build such a canal had been around for some 300 years. A canal connecting the Pacific Ocean to the Atlantic would have shortened the route of ships by thousands of kilometers. Ships would also have been able to avoid the hazardous route around Tierra del Fuego. In 1876, the ambitious project was taken up by a gentleman experienced in such undertakings. This was Ferdinand Lesseps, the French engineer and author of the Suez Canal. It was to be one of the most expensive construction projects in history. Works that were preceded by extensive clearing of Panamanian forest and difficult grading. Engineers had to tackle a mountain range, through which they cut a narrow artificial valley, the so-called Colera Cut. The plight of the workers who had only primitive tools was made worse by heavy rain and landslides. A yellow fever epidemic killed hundreds of labourers every month. Unsurprisingly, the work slowed down and costs went up. Neither the concealment of inconvenient truths to investors or the national lottery could save the company from bankruptcy and the French government from scandal, as ministers were accused of taking bribes. Among the accused was the engineer Gustave Eiffel, who had come aboard to create a series of locks as typically found on canals. The project ground to a halt, and Ferdinand Lesseps died in disgrace. But 17 years later, the project was taken up by the US government.
Not only on construction itself, but also on planning of such a structure, they need to take precaution of different effects of geology, of hydraulics, of power supply, etc.
The Americans bought the land with the remains of the unfinished canal for $10 million US. President Theodore Roosevelt put John Stevens in charge of the work. Thanks to heavy machinery, the workers managed to excavate as much soil during a single day as the French had managed in a month. Attacks of yellow fever also decreased. So far, so good. In May 1906, however, the Chagres River flooded with landslides destroying mining machinery. His spirits crushed, Stevens began to question the entire project, proposing instead a system of locks as begun by Gustave Eiffel. A few months later, Stevens was replaced by one Colonel George Goethals. Ironically, Goethals supported the idea of a system of locks. Under his leadership, locks were built near the artificial Gutan Lake on the Caribbean coast, and Pedro Miguel and Miraflores locks were built at the entrance to the Gulf of Panama. Breakwaters were constructed near the approach channels to both oceans. In October of 1913, the works of the Culebra Cut were successfully completed. The first ship sailed through the canal the following year. The over 77-kilometre-long canal is crossed by several bridges. The most famous, the Bridge of the Americas, is located in Panama City. For many years, it served as the main bridge of the Pan American Highway. Even today, the engineers are still finding ways to improve the Panama Canal, extending its paths and making the transport system flow faster. The Interstate Highway System, United States. It seems hard to believe nowadays, but the United States of America only began building its interstate highway system in the 1950s. Champion of this project was Dwight Eisenhower, legendary American general and president. It was thanks to his initiative that the crucial Federal Highway Act was adopted on June the 29th, 1956.
But the origin of the system was not only to move people from one side to the other, but also to be prepared for the World War.
The path to making the Federal Highway Act a reality was a bumpy road, despite the support of Ike. Opponents thought that building a road network was an enormous waste of money. But the 1950s were marked by the Cold War and the threat of nuclear conflict. So when the network started to be discussed in terms of national security, its opponents eventually gave Eisenhower's proposal the green light. Eisenhower will forever be connected to the interstate highway system in ways quite personal to his life and career. The first was back in 1919, when the still young Major Eisenhower was a part of an army convoy from Washington, D.C. to San Francisco. The purpose of the convoy was to test vehicles, road quality, and transport speed in the event of war. On the existing network of roads, 81 military vehicles moved at average speeds of a mere 6 kilometers per hour, leaving a lot to be desired.
Even if you get all the cars driving on green kind of electricity or some other green innovation, but then it still takes up so much space that it will be a big change, I guess.
The second experience, which convinced the future president the US would need modern highways, was the march of the victorious American army across Nazi Germany. Eisenhower was impressed by the Reich highway system, the Reichsautobahn. Back in the peacetime US, the 1956 Federal Highway Act allowed for the construction of 41,000 miles of highways at a cost of $129 billion. According to the letter of the law, 90% of the construction was to be financed by the federal government, with the remaining 10% coming from individual states. The government drew the necessary funds from higher taxes, levied on each gallon of gasoline sold. At the same time, the government set strict standards and specifications like multi-lane roads or interchanges, of which there are now 16,000 in operation. Final construction of the US interstate highway system was only completed in 1981, and this network still has the densest traffic and highest speed limits in the world. The average speed limit is around 70 miles per hour, but it can go significantly higher. The routes are laid out in a checkerboard pattern. Even-numbered routes go from north to south, while odd-numbered routes indicate connections between east and west.
We can mention also the system riding in the convoy, so many cars can join with the automatic system. So there are many tools and many inventions that can be placed in the highway system.
Although the massive project was continued by Eisenhower's presidential successors, such as John F. Kennedy, Lyndon B. Johnson, and others, the interstate highway system bears the name of its founder, Dwight Eisenhower. That's why even today, you can find the inscription Eisenhower Interstate System on most highways, under a circle of white stars on a blue background. The megastructures we have looked at together represent the three essential modern transport systems. That is to say, rail, ship, and road. Each megastructure is a masterpiece of its time, enriching and simplifying the lives of many millions worldwide. These hugely ambitious creations often took decades to build and involved astronomical financial costs, but also a considerable degree of human sacrifice. On balance, though, the costs in monetary terms and even blood, sweat and tears were not in vain if we consider the progress in science, technology and quality of life these mighty megastructures brought with them. Humanity has been bestowed with great gifts. Perhaps greatest of all is our imagination, because ultimately, it's our imaginations that enable us to shape the world around us. The most obvious examples of that are the great buildings and architecture all around us. But which works of architecture should we see during our lifetimes? Find out in Top 10, The Art of Architecture. Museums are treasure houses of human history. In the past, they were usually private, and only after time did their collections become accessible to the wider public. Buildings dedicated to storing, preserving, and displaying collections started to emerge, whether by transforming existing buildings or by erecting brand new purpose-built edifices. The 10 museums we look at in this episode are some of the most visited buildings in the world, each one rightly famous for its impressive design. Guggenheim Museum, Bilbao, Spain. On the left bank of the river Nervión in Bilbao, the largest city of Spanish Basque Country, stands the distinctive Guggenheim Museum, Bilbao. Designed by the world-famous Canadian-born architect Frank O'Geary, it is a groundbreaking exemplar of 20th century architecture. Housing modern and contemporary art, the Guggenheim Museum Bilbao is one of the 3 museums operated by the Solomon R. Guggenheim Foundation, founded back in 1937. In the late 1980s, Basque authorities put a lot of energy into revitalizing Bilbao, and in 1991, they approached the Guggenheim Foundation about the building of a museum in Bilbao's former port area, displaying treasures from the Guggenheim collection.
And if you compare that with some other modern museums that have been built since then, the balance can kind of tilt over a bit, that the architecture takes over the space and the art becomes secondary in the thing. And then it becomes difficult.
The foundation chose a boldly idiosyncratic design by Geary, who in 1989 had been awarded the Pritzker Architecture Prize, the Nobel Prize of Architecture. Geary designed a curved, irregularly shaped titanium glass and limestone structure supported by steel. The building is coated with around 33,000 titanium sheets that reflect light and change color according to weather and light conditions.
This building has actually become a representative for a whole way of thinking.
Construction on the 32,000 plus square metre site started in 1993, and the museum was opened 4 years later by the then King of Spain, Juan Carlos I. The heart of the museum, and one of its signature features, is the atrium, around which are the 3 floors which house the galleries. 50 meters high and with large glass curtain walls, the atrium is flooded with light and capped by a huge metal skylight in the shape of a flower. The museum's 20 galleries are connected by a network of curved catwalks, staircases, and glass elevators. They provide different perspectives on the exhibition spaces, which take up approximately 11,000 square meters. Some of the galleries are built along classical lines, while others are more irregular or organic in their proportions.
You don't know anything about the inside of it, but you have the feeling when you see all these forms that maybe how is the proportions? Nobody tells you about that, or what is inside actually.
The largest gallery is 30 meters wide, 130 meters long, and completely free of columns. It houses Richard Serra's monumental installation, The Matter of Time, which consists of his 100-meter-long steel sculpture, Snake, and 7 newer sculptures positioned around it. Outside the gallery, a motorway bridge was cleverly incorporated into the museum's exterior design. The Guggenheim Museum Bilbao, half sculpture, half building, is one of the world's most spectacular buildings in the deconstructivist style. The most important building of Gehry's architectural career. It is an instantly recognizable icon of the city of Bilbao. The Rijksmuseum, Amsterdam, the Netherlands. The first Rijksmuseum originally opened to the public in 1800 as the National Art Gallery in The Hague. In 1815, the entire collection was shifted to the new capital of Amsterdam, and the museum was given its present name, the Rijks, or Imperial Museum.
And by analyzing existing architecture and also you can learn a lot about it.
The present building on Museum Square was first opened in 1885 after 9 years of construction. It was designed by the Dutch architect Pierre Cuypers, also responsible for Amsterdam Central Station and numerous churches in the Netherlands. His neo-Gothic red brick design for the Rijksmuseum mixed Gothic and Renaissance styles and employed materials and decorations lifted straight from Dutch art. Looking not unlike a fairy tale castle from the outside, the interior was divided by a thoroughfare creating 2 inner courtyards. The facade was richly decorated with reliefs, sculptures, tiles, and stained glass windows. While the interior was adorned with murals, mosaics, and rectangular columns. Numerous alterations were made during the 20th century in order to do away with any interior decorations which competed for attention with the masterpieces on display. Colored walls were whitewashed, and additional exhibition rooms were added to the 2 courtyards. From 2004 to 2013, the museum went through a major refurbishment. Directed by the Spanish architects Antonio Cruz and Antonio Ortiz. They combined the museum's original layout with modern facilities, climate control, and security features. Probably most impressive was the transformation of the courtyards into a double atrium, linked by a passageway below. This created a new entrance hall to the museum. Glass vaults in the atrium meant sunlight was restored to the courtyards. The auditorium and museum shop below the limestone floors are now at 9.25 meters below sea level.
You can actually strip down a lot of old buildings to their organization and their structure and the ideas. And there's some very, very nice ideas in a lot of these old buildings.
In some of the museum's main halls, including the Night Watch Gallery, designed to showcase Rembrandt's world-famous painting of the same name, a team of restoration experts went to work. The gallery's interiors had originally been designed by the French designer Jean-Michel Wilmot, most famous for his interiors in the Musée du Louvre. The museum presents the world's largest collection of Dutch paintings from the 15th to the 19th century, but is most celebrated for its paintings from the 17th century, golden age of Dutch art, including the work of artists such as Rembrandt and Frans Hals. Today's Rijksmuseum is case study of how creative solutions responded to the challenge of renovating a building already considered a national treasure. Eventually, it was not so much renovated as reinvented. Museum Anderstroom, Antwerp, Belgium. This museum is the youngest of all the buildings in our top 10, and the only one where the permanent exhibition is not devoted to fine art and art history. Instead, this museum's focus is on ethnography and the history of the Belgian city of Antwerp, and by extension, the world to which Antwerp has been connected for centuries, via its thriving seaport. The museum on the river, or the Maas for short, is located on the right bank of the River Scheldt, between the two oldest docks in Antwerp, on the site of the former Hanseatic House, an important trade and shipping office and warehouse well until it burned down in 1893. In 2000, the Dutch architectural firm Nutelings Reidetschik won the tender to design the new museum building. Actual construction took 4 years, from 2006 to 2010. The museum opened with the exhibition Masterpieces in the Maas, 5 Centuries of Images in Antwerp, contrasting the city depicted by the 16th and 17th century masters with that of contemporary artists.
It's the same as in the Centre Pompidou. You see the people on the outside moving across the facade, and you can understand the building when you look at it from the outside. And I think that's important, to give people a chance to actually understand the building.
The 10-story rusty red warehouse is in some ways an homage to the 19th century warehouses typical of the Harbour district. It also resembles a pile of gigantic boxes piled one on top of the other. The 60-metre-high tower is supported by a central concrete core encasing elevators and fire escapes. Steel frames, which can be seen inside the exhibition halls, are suspended from the core. The outer walls of prefabricated concrete panels are attached to the ends of these frames. Thus, the whole exterior becomes an adjustable space.
One level with that, then they turn it a bit, then it's glass, then they turn it a bit and it's bricks. It's a playful thing with a high house.
A facade of corrugated glass can be rotated a quarter turn at each level of the building. These corrugated curtains of glass are 5.5 meters high. The interior space with an escalator inside forms a kind of large spiral staircase, affording constantly changing views of the city. The building is covered by large panels of hand-cut Indian red sandstone, with a computer-generated 4-colored mosaic pattern. A recurring motif are metal ornaments in the shape of hands, symbol of the city of Antwerp, which adorns the exterior. The same pattern is repeated inside. The square at the foot of the tower is made from the same natural red stone and is an ideal space for events and open-air exhibits. Construction of the Maas was part of the redevelopment of the Harbour district, which is coming back to life as old warehouses are converted into lofts and several other large public buildings have opened. The Maas, the largest museum in Antwerp and a unique public space, has become an icon of this dynamic urban renewal. The Uffizi Gallery, Florence, Italy. The museum with the finest collection of Italian Renaissance paintings is, unsurprisingly, located in Florence, Italy. The city's historic centre was listed as a UNESCO World Heritage Site in 1982. The Uffizi Gallery is close to the Ponte Vecchio, the famous bridge across the river Arno, and the Palazzo Vecchio, Florence's town hall, in front of which proudly stands a replica of Michelangelo's David. The gallery is housed in the Palazzo degli Uffizi, which was commissioned by the Duke of Florence Cosimo I de' Medici in 1559 to hold all of the various Florentine offices, or Uffizi in Italian. It was designed by the famous painter and architect Giorgio Vasari. It was, however, Cosimo Medici's son and successor, Francesco I, who insisted the top floor of the Uffizi become a repository for the Medici art collection. The gallery was created in 1581 on completion of its east wing.
In more historical buildings, you walk kind of often through the rooms in the center of it. So you will enter a room and then you have the exhibition all based on the fact that you hang paintings on the walls around it. And then you kind of enter through from one room to the other or along the galleries at the side where you kind of go into these spaces.
This gallery was only accessible to certain VIP visitors. But in 1769, the future Holy Roman Emperor, Leopold of the House of Lorraine, inherited all of the Medici property when the dynasty finally came to an end. It was Leopold who first opened the gallery to the public. A classic example of architecture from the late Renaissance Mannerist period, the palace forms a U shape with a long and narrow open courtyard lined by a double loggia of columns, which connects with the river Arno and the Piazza della Signorina. A portico opens up from the courtyard to the river and forms a picture that is most pleasing to the eye. The symmetrical outline of the building's exterior is not, however, repeated within. An irregular ground plan is divided into halls and corridors of various shapes and sizes. The ground floor also incorporates remnants of a Romanesque church, one of the many buildings demolished before work first began on the construction of the palace. But the heart of the gallery is the domed octagonal hall on the second floor. Known as the Tribuna, it displays the most important masterpieces from the Medici collection.
In the old days, when they exhibited paintings in these rooms, you had the walls covered with paintings. You actually didn't have this thing like you have in modern art, where you have a big white wall and you have this single painting, but you have 20 paintings on the walls.
Over the centuries, the gallery has continued to expand from the top floor to the lower levels. The museum's exhibition space has also doubled in size over the past few decades due to constant renovations. The palace was arguably Giorgio Vasari's finest architectural achievement and a true masterpiece. The first building in Florence that was fully conceived as a model of urban design. The beautiful views of the Uffizi from across the Arno are testimony to Vasari's visionary genius. Hermitage Museum, St. Petersburg, Russia. Founded in 1703 and once the shining new capital of the great Russian Empire, Today, St. Petersburg is Russia's second largest city, situated just 100 kilometers from the border with Finland. The city is home to the Hermitage Museum, which contains a vast collection of some 3 million works of art, including some of the most important European artists.
Four buildings for different purposes in the beginning, and they are mirroring in the water.
The museum is housed across 7 buildings from the 18th and 19th centuries. 5 of the buildings make up a formidable interconnected palace complex on the banks of the river Neva. This includes the Winter Palace, former imperial residence of Russian monarchs. Since its conception in 1753, the already colossal Baroque Winter Palace, with more than 460 luxuriously decorated rooms, was continually expanded by the Tsars. In 1764, Empress Catherine the Great soon ordered that a new wing, effectively another palace, be added to it. Intended as a place of retreat from the formalities of the court, she named it the Hermitage and furnished it with at least 225 paintings by Flemish and Dutch masters.
Even though these buildings are quite monumental, there is still some peace in it, I think, in this very organized way of doing a building.
The Hermitage, now known as the Small Hermitage, was built in 2 stages. First, the Russian court architect Yuri Veltin combined the Baroque style with the new fashion for neoclassicism to create the Southern Pavilion. In the second stage, French architect Jean-Baptiste Vaillant de la Motte built the Northern Pavilion, adopting the more austere neoclassical style. The 2 pavilions were then connected by hanging gardens and galleries to complete the Small Hermitage in 1775.
In museums of modern art, you need a completely different flexibility from what you needed in old museums, where you would traditionally have rooms where you place sculptures, and you have rooms where you hang painting from the walls.
Catherine the Great bought up masterpieces in large quantities to create a collection comparable to those of other European monarchs. Not finished yet, she ordered the construction of a larger building next to it on the embankment. This neoclassical building was named the Great Hermitage and was intended to house all the palace collections plus the library. Catherine's grandson, Nicholas I, commissioned the new Hermitage, Russia's first purpose-built art museum. It opened to the public in 1852. The remaining 2 buildings of the Hermitage complex are the Hermitage Theatre and the Winter Palace. This was declared a museum in 1917 after the October Revolution overthrew the Romanov dynasty. In the Hermitage Museum, European design still features strong hints of traditional Russian architecture, while the splendid exhibition halls are a monument to the bygone imperial dynasty. No wonder it has been dubbed the Russian Louvre. There are many museums not just popular with visitors for the artifacts they have on display, but due to their architecture. The 20th century was an especially rich era in museum design, spawning creations which would become icons of their host cities. In the instance of buildings from an earlier time, one can admire their grandeur, but also think back on the historic events to which they stood silent witness. or in some cases, those events which swept right through them. British Museum, London, UK. Although the building is not as grand as the Hermitage, the collections at the British Museum in London are more than twice the size of its Russian counterpart. Indeed, the British Museum is home to one of the largest permanent exhibitions in the museum world. The British Museum was first established in the 18th century, when the physician, naturalist and collector Sir Hans Sloane bequeathed his private collection to king and country.
In historical times, it was often a show of wealth and what you have. And in modern times, one has started, I think since the 80s, 70s, 80s, started using museum as an impulse.
The British Museum was originally housed in a 17th century mansion, which stood on the present site in the Bloomsbury area of central London. However, after the King's Library, a collection of books created by George III, was donated to the nation, a new building was needed. The new quadrangle building surrounding a large central courtyard with 4 wings and a grand south front was designed by leading English architect Sir Robert Smirke in 1823. Smirke designed the building in the then popular Greek Revival style. This style is apparent on the south entrance, with its stairs, rows of columns, and crowning pediment. However, Smirke was no mere slave to tradition, but a genuine innovator. He used the cutting-edge technology of his day. The frame of the building was made from cast iron and embedded in concrete foundations. The walls were made of brick, and the facades were encased with limestone.
The most important for a building is, of course, that it functions for the use of it.
The first completed wing was, of course, dedicated to the King's Library. The grand double-height room is characteristic of the so-called Age of Enlightenment. Its size was made possible by the pioneering use of cast-iron beams to support the ceiling. The building was officially completed in 1852. And yet, construction works continued as more space was needed to contain the ever-expanding collections. And so, over time, other buildings in the block surrounding Smirke's quadrangle became integrated into the museum. As early as 1857, a separate reading room was built in the middle of the courtyard. A masterpiece of mid-19th century technology, the 42-square-metre domed room was constructed using cast iron, concrete, glass, and with the latest heating and ventilation systems. At the turn of the 21st century, the whole inner courtyard was enclosed by a glass roof with the reading rooms at its centre, making it the largest covered public square in Europe. But arguably, the most spectacular aspect of the British Museum are its collections, which come from all over the world. They include antiquities from the great ancient civilizations. Most controversially, there are the Elgin marbles, classical Greek sculptures taken from Athens at the start of the 19th century. With its huge variety of exhibits, the British Museum sheds light on virtually every epoch in the history of mankind. National Museum of Modern Art, Paris, France. The second largest collection of modern and contemporary art in the world, after the Museum of Modern Art in New York, is to be found at the National Museum of Modern Art in Paris. The building that accommodates this collection is as famed as any of the artworks within. Indeed, Centre Pompidou is possibly the most radical example anywhere of structural expressionism, the so-called high-tech architecture of the 1970s. A style known for displaying the structural components of buildings on the outside as well as the inside.
What is fascinating with that building is that what they have done there is that they've actually managed to create these very, very large, through a very complex construction, very large spans, big spaces where you can really exhibit anything.
In 1969, President Georges Pompidou commissioned the construction of a cultural centre that would place the National Museum of Modern Art, an important public library, and other cultural projects all together under the same roof. The competition to design the new building attracted 681 competitors from 49 countries. And in 1971, the jury announced the winning design. It was the work of a team of 3 architects, Renzo Piano and Gianfranco Francini, and the Englishman Richard Rogers. All 3 were relatively young and unknown at the time, but Piano and Rogers were both later awarded the Pritzker Prize, the Oscar or Nobel Prize of Architecture. In simple terms, the Centre Pompidou is a building turned inside out. On the exterior, all the services, lifts and escalators, wiring and piping rest on a metal frame, leaving the vast interior space uninterrupted by load-bearing structures and thus capable of multi-purpose adaptation. Facilities for moving people around, such as lifts and escalators, are concentrated on the western side of the structure, towards the plaza below. But all of the technical equipment and pipelines are on the opposite side, muffling the sound of the traffic from the street, with some 15,000 tons of steel and 11,000 square meters of glass. A truly pioneering building was the result, a worthy heir to the great iron buildings of the industrial age.
Pompidou really celebrates the art and the movement of the people. It's a very people-based building, a very democratic building.
Four boldly distinctive colours brighten the facade of the Centre Pompidou, following a code laid down by the architects. Blue for air conditioning, yellow for circulating electricity, green for the circulation of water, and red for the movement of people, such as escalators and elevators. Named after President Pompidou, who died in 1974, the centre was completed in 1977. It has since become one of the most visited monuments in France, both for its influential exhibitions of contemporary art and as a triumph of architectural engineering. Futuristic in so many vital aspects, its revolutionary character has made the Centre Pompidou an emblem of 20th century architecture. Tate Modern Gallery, London, UK. As fine example as there is of the adaptation and repurposing of an existing building, the former Bankside Power Station in London houses the modern and contemporary art of Tate Modern, jewel in the crown of the Tate family of galleries. Tate Modern was originally founded by Henry Tate, owner of a number of sugar refineries. He donated his collection of paintings to the nation, contributing large sums to the redevelopment of the gallery building.
The point at which the art entered the museum, that's when the building was fulfilled. Before that, it was uninteresting, actually.
A coal-fired power station had existed at Bankside since 1891, but was replaced by a new, more environmentally friendly oil-fired station on the same site in 1947. The Bankside power station, later reused by Tate Modern, was designed by Sir Giles Gilbert Scott and is an imposing steel-framed and brick-clad building typical of the era. It consisted of a huge turbine hall which housed the electricity generators and a boiler house parallel to that.
But with the Tate Modern, you have, in a way, a very monumental, very great existing building. And I think what they've managed to do is to keep quite a low profile and to leave these big and use these big spaces, the big entrance space.
There were two chimneys, one at each end of the building in the original plan, but only one central 99-metre-tall chimney was actually built. Any structure that might have dwarfed St. Paul's Cathedral across the Thames was considered in bad taste. The new power station was constructed in two stages. The western half and the chimney between 1947 and 1953, and the eastern part between 1959 and 1963. But in October 1981, the power station closed because of increasing oil prices and pollution. At first, there were plans to demolish it. This, despite the fact the building was already considered an architectural achievement worthy of preservation. Fortunately, in 1994, it was selected as the site for the new Tate Gallery. Swiss architects Herzog and de Meuron, who were later awarded the Pritzker Architecture Prize, were commissioned with its redesign. Their outlines retained much of the original character of the power station. The turbine hall became an impressive entrance hall and display space for large sculptures and installations. The boiler house was given a two-story glass extension to become gallery space. Seven gallery floors were created using a steel framework built within the existing walls of the power station. This framework also supports the brick facade. The building was sealed watertight, and environmental controls, permanent lighting fixtures, stairs, lifts, and escalators were all installed.
The interesting thing is that the building comes from a time when industry was celebrated. So if you would do the same thing now and take an industrial building that was built in the 80s or 90s and convert that to a museum, it would be much more difficult.
Since it opened in 2000, Tate Modern has attracted millions of visitors each year who also come to admire Shakespeare's Globe, just next door, and the Millennium Bridge. Tate Modern is now a success story of urban regeneration and the reuse of an otherwise obsolete building. But the story of Bankside Power Station is not over yet. After converting the power station's 3 huge underground oil tanks into a performance and exhibition venue, Tate Modern is now in the process of completing a new 11-story building. This is situated above the boilers and will allow for even more exhibition space. Louvre, Paris, France. One of the largest and most famous art museums in the world came about as the direct result of a bloody revolution, the French Revolution to be precise. The Louvre Palace had previously been the Parisian residence of French royalty before it was transformed into a museum and opened to the public in August 1793, just before the onset of the so-called Reign of Terror.
And on the one hand, the old Louvre is very traditional. It has these rooms and these corridors and a lot of paintings, and you used to have to go in on one side, and then you would kind of walk through hundreds of 18th, 19th century French paintings, which one can like or not like, before then all the tourists arrived at the Mona Lisa.
The Louvre stands on the right bank of the River Seine and comprises a complex of wings and pavilions which surrounds two large courtyards, the Renaissance Cour Carrée, the square courtyard, and the larger 19th century Cour Napoléon, the Napoleon courtyard. The Louvre was built on the site of a former fortress that was demolished in the 16th century by King Francis I in order to make way for a new royal residence. It was Francis who initiated the vast art collections to be handed down to generations of French royalty. His acquisitions included what is now the most famous painting in the world, Leonardo da Vinci's Mona Lisa.
They renew it with this glass pyramid in a sort of postmodernistic style, you know? And it looks very beautiful inside there.
The architect of the new palace was Pierre Lescot, and indeed the oldest part of today's Louvre bears his name. The architect of the Lescot wing was influenced by Mannerism, not unlike the Uffizi Gallery in 16th century Italy. Over time, the royal residence gradually developed in the styles of French Baroque and Classicism. The Palais de Tuileries was linked to the Louvre Palace, and the architect Claude Perrault completed the Cour Carrée with a masterfully constructed row of columns. In the 19th century, already a working museum, the Louvre underwent the largest extension in its history. Two major wings extending west were added, creating the Napoleon courtyard. By 1871, the Louvre had arrived at something like its present shape.
And then came Pei, and he said, wait a minute, you know, we put an entrance in the middle, and then we start spreading from there.
At the end of the 20th century, the museum was modernized and extended yet again. Amenities were constructed beneath the Napoleon courtyard, with the main entrance to the museum now situated in its center. Most controversially, in 1989, the entrance was graced with a glass and steel pyramid designed by Chinese-American architect I.M. Pei. He also oversaw renovations to the wing, which once housed France's Ministry of Finance. This means that the whole of the Louvre Palace complex is now an art museum. The present-day Louvre displays more than 35,000 works of art, and its collection of French paintings from the 15th to the 19th century is unparalleled. But the site is also exceedingly rich in architectural styles and artifacts from many major eras in world history. "30 years ago, the pyramidal entrance was intended to receive 4.5 million visitors a year, but now welcomes more than twice that number. This makes the Louvre the second most visited museum in the world, after the Palace Museum in Beijing. our final destination for this show. Palace Museum, Beijing, China. The Palace Museum in Beijing is indeed the most visited museum in the world. Like the Louvre in Paris and the Hermitage Museum in St. Petersburg, it is housed in a palace, though one rather different in design. The Palace Museum is located in the Forbidden City, the residence of Chinese emperors for almost 5 centuries in the center of Beijing.
It is this philosophical way of thinking, and I think the whole Forbidden Town is based on this philosophy.
After Zhu Di of the Ming Dynasty became Emperor of China, he ordered an imperial palace to be built in Beijing. The palace was thus constructed between 1406 and 1420. Centuries later, in 1925, it was declared a palace museum. This after the last emperor had been overthrown and the People's Republic established in China. At that time, more than 1 million items were listed in the museum collection. That number has risen to more than 1.8 million. A UNESCO World Heritage Site since 1987, the Forbidden City is a 72-hectare rectangular walled complex measuring 961 meters north to south and 753 meters east to west, situated along a central north-south axis. This follows the traditional Chinese system of feng shui. There are hundreds of halls and palaces made of wood, red brick and white marble with painted ridges and carved beams topped by yellow roofs, spread out on both sides of the central imperial way. However, because these buildings were usually supported by wooden frames, they were susceptible to fires. Extensive reconstruction works were therefore common over the years. Yet all the work done over the centuries has respected the original design.
And the roofs are in tiles, and in the Forbidden City they are yellow. All the roofs are almost yellow.
At its heart are 2 large courtyards, the outer court, site of the emperor's court and his grand audiences, and the residential inner court. Each wall of the city has a gate, but the main entrance has always been from the south through the Meridian Gate. This is one of the tallest buildings in the entire complex. Beyond the gate lies a courtyard containing the inner Golden Water River, traversed by 5 white marble bridges. The river leads to the Gate of Supreme Harmony, which in turn opens onto the outer court. In the outer court stand 3 main halls. One of these, the Hall of Supreme Harmony, in the very center of the Forbidden City, is the largest and most imposing. Serving as the throne hall, it is lavishly decorated. Golden dragons adorn its exterior and interior, and the 10 figurines of each of its roof corners proclaim its imperial pedigree. With collections representing 5,000 years of Chinese civilization, the Palace Museum is a masterpiece of Chinese imperial palace architecture, illustrating the grandeur of the Ming and Qing dynasties. There is great diversity in the buildings housing some of the world's most visited museums, but they all have one thing in common. They are dedicated to preserving and passing on cultural heritage for generations to come. In order to do this, the designers of museums have continually found new ways of displaying their collections, sometimes constructing bold and attractive new buildings, at other times redeveloping and renovating old and historic buildings. Either way, there can be no doubt that such museums represent some of the finest achievements in the history of architecture.